9.5, angles of elevation and depression. And here's a picture, and I've got this on the next page too. Angle of elevation, basically when you're looking up. Angle of depression when you're looking down. We might do something cheesy in the class to reinforce that. Your angle of elevation, and I do want you to write this in your notes, the angle between the line of sight, so I'm going to highlight angle of elevation. It's the angle between your line of sight and the horizontal when the observer looks upward. So there, I'm sorry, I highlighted the wrong thing. Line of sight is this up one, here's the horizontal. So this angle right here is your angle of elevation, which seems rather obvious. Okay, I'm going to clear that out. Angle of depression, the angle between the line of sight when an observer looks downward. I think that's supposed to be from the horizontal. So here is the horizontal. Let me go back to the highlighter. And then the observer looks downward. So the angle that's created is your angle of depression. That little piece between those two. Okay, make sure that's in your notes. Example 1, at the circus, a person in the audience at ground level watches the high wire routine. A 5-foot, 6-inch tall acrobat is standing on a platform that is 25 feet off of the ground. How far is the audience member from the base of the platform? If the angle of elevation from the audience member's line of sight to the top of the acrobat is 27. So let me point out the horizon is like right there. And then the line of sight is 27 degrees, and we're talking about that one because it says to the top of the acrobat. Okay, I'm going to clear that out. So now what do we have to focus on? And why did they give this other little thing in here? Because they were kind of sneaky, nice that they drew a picture. 25 feet to the bottom of the acrobat, and then you have to add on another 5 feet, 5.5 feet. Remember, 6 inches is half of a foot. So let's add that together, 30.5, and then we are now looking at this triangle. We have a right triangle. Okay, your angle of elevation is 27 degrees. You have 30.5. What do they want us to find? How far is the audience member from the base of the platform? How far is this person from the base of the platform? So this is my X down here. So now I have an opposite from this angle here, and I have an adjacent. So I'll be using tangent. So tangent of 27 degrees is 30.5 over X. This is a new one. Now I think Mr. Risbrood, if you've had him, he has kind of a special way of explaining this. I'm a little more mathematical in this. Who wants to solve for an X in the denominator? Not me, so I get it out of the denominator. And I do that by multiplying this side by X, and what I do to one side of the equation, I must do to the other side of the equation. These X's cancel. So now I have X tangent of 27 degrees is equal to 30.5. So now divide both sides by tangent of 27. Make sure your calculator is set to that degree mode. Okay, and then you grab your calculators, and we're going to take 30.5, and we're going to divide it by tangent of 27. And I'm getting 59.8, so I think 60 will be fine, unless it says I have to do a certain particular thing here. What am I measuring in? It looks like I am measuring in feet. Okay, so the observer is 60 feet away from the base of the platform. Example number 2. A roller coaster car is at one of its highest points. So there's a roller coaster going up and down, up and down. We're going to just say right here. Okay, it drops at a 63 angle of depression for 320 feet. So the roller coaster is going down here, it's going down. Now, angle of depression, isn't this the line of sight, the horizon? Isn't this the depression right there? So isn't that my angle there? 63 degrees. Now, you have a couple of choices. If you're already thinking, there's my horizontal, well then you can just kind of make your triangle out of that. I also have students who will go the other way and make their triangle this part. In the end, it doesn't really matter. Okay? Here's your right angle. I'm going to work with the green, the original one that I had. And what am I supposed to find? How long is the vertical distance of the drop? Basically, how far is this amount? Okay, so now I have opposite and a hypotenuse. So that's going to be sine. So sine of 63 degrees is equal to the opposite over hypotenuse, which is 320. All right, and to solve for x, I take both sides times 320, take this side times 320, and I calculate 320 times sine of 63, and I'm getting 285.1. I'll just leave it 285, and it appears that we're talking about feet, so 285 feet. All right, example 3. Vernon is on the top deck of a cruise ship and observes 2 dolphins following each other directly away from the ship in a straight line. So one dolphin is following the other dolphin. Vernon's position is 154 meters above sea level, and the angles of depression to the 2 dolphins are 35 and 36 degrees. Notice how they drew that in. This is your horizontal, and this is your depression right there. I know a lot of kids, they want to put it right in here. You can see that mistake happen really easily. Find the distance between the 2 dolphins. Sneaky, sneaky. All right, so what we want to do here is we're going to start with this first triangle. In fact, you know what I think I want to do in this case? I'm going to undo that. Can I do that? All right, I'm going to find this distance right down here, my green distance, and then at later time I will find the red distance from here to here, and then I'll go from there. Okay, so my green distance, how am I going to work on that when I only know this up here? Well, isn't this a right angle? I've used up 35, I've used up 36. So let's start with the big triangle, which has used up 35. So 90 minus 35 is 55 degrees. So I'm going to use 55 degrees up here. What else do I know? I know this piece right here is 154. So there's my triangle. All right. And if I have this, then I have adjacent. And I have the degree marking, and I want to find x way down here. So I have adjacent, and I need the opposite. So I'm going to use tangent of 55 degrees is opposite over adjacent. So x over 154. Use my calculator by taking 154 times tangent of 55 degrees. And now I have x is equal to 219. I think I'm going to be a little more detailed here, 0.93. Oh, it says to the nearest meter, but let me work in detail and then I'll round later. All right, now I'm going to work in red. I'm going to find this distance, which is y. This is still 154. I'm still going to be using tangent, except now this is going to be 54 degrees. 54 and 36 is 90 degrees. So I will use tangent of 54 degrees is equal to opposite over adjacent. Type it into my calculator. And I'm getting 211.96. And now they want to find the distance between the 2 dolphins, so I'm going to take the 219.93, subtract that, or subtract 211 from that, and I'm getting 7.97, and it says round to the nearest meter, so I will say 8 meters. And we're done. That's it for that. Ooh, that's it for that section.